We're about to embark on the sketching of a trig function, and it's going to be quite involved, so we're going to do it step by step, slowly through it, but it's using all the 8 steps that we have established in the last examples. So the first thing is to figure out the domain, and the domain is all real numbers because it's a trig function and there's no restriction. Now the intercepts. The x and y intercepts, we'll start with the y-intercept, which is when x is 0, so it's cosine of 0 squared minus 2 sine of 0, and cosine of 0 is 1, so it's 1 squared minus sine of 0 is 0, so it's minus 0 equals 1. So the y-intercept is 0, 1. The x-intercept is a little bit more complicated to figure out, and that's because you're solving a trig equation. So here we go, and I'm going to change this to a sine function using the identity 1 minus sine squared x equals cos squared x. So this is a Pythagorean identity, and I'm changing the cos squared into sine squareds that way. And I'm going to rewrite it with the leading coefficient being the squared, or the leading term being the squared term, then the linear term, and then the constant. And unfortunately, it would have been nice, but this doesn't factor. So that means that I have to use the quadratic formula. So x, it's actually sine x equals negative b plus or minus b squared minus 4ac over 2a. And b is negative 1, so that's going to be 1 plus or minus b squared, which is 4. Sorry, this was 2 here. It's positive 2. I didn't circle the whole thing. B squared minus 4 times a times c, all divided by 2a, which is going to be negative 2. And that works out to be 2 plus or minus the square root of 8 over negative 2. And if you solve that just using your calculator, you'll get 2 answers for sine x. One is negative 2.41, and the other one is x equals 0.414. And now we need to find what x is, and x cannot be, if you think about sine function, the sine function looks like this. It will never reach negative 2.41. It only goes down to negative 1, so there's no solution out of this one. Here I'm going to take the inverse sine, and I get x equals the inverse sine of 0.414, and I have my first answer, which is 0.427. And know that the sine function is positive in 2 quadrants. We've just figured out this one, so the second answer is 2.71. And so that's pretty complicated there for just finding the x-intercepts. Moving on, we need to now take the derivative. So I'm just going to write the original question out again, which is cosine x. And I'm going to write it like this so it's easier for me to do the chain rule. And now I'm going to take the derivative. So prime of x, I'm going to move the 2 out front, keep the inside the same, and multiply by the derivative of the inside, which is negative sine x. Next piece, take the derivative of sine, which is cos x. So simplifying that expression, I'm going to get negative 2 sine x cos x minus 2 cos x. And I am going to factor this because I know I'm going to have to put it on a number line to figure out where it's increasing and decreasing. So I'm going to take out a negative 2 and a cos x, and that leaves me with sine x plus 1. So that factored quite simply, and I'm now going to place that on the number line. And before I figure out what numbers are going to be important on the number line, I'm going to solve this for where it's equal to 0. So where's the cos x equal to 0? If you remember, the cosine graph looks like this. Then the cosine graph is equal to 0 at x equals 0 and at x equals 2 pi. That's in the first cycle. And where is the sine x equal to -1? Well, the sine x, the graph looks like this. So when it's equal to -1 at 3 pi over 2. So x equals 3 pi over 2. Now before I move on to put this on the number line, I forgot one step, and that was the symmetry of the graph. So the symmetry, jumped over that unfortunately, the symmetry, it's not even or odd, but it is periodic because both of these have a period of 2 pi. So the symmetry, it has none, but it is periodic. And it's periodic with a period of 2 pi. And what that allows me to do is I need to analyze everything between 0 and 2 pi, and that's it, because now I know that it'll repeat after 2 pi, so I don't have to go on to make the number line infinitely long. I can just look at the little window between 0 and 2 pi. So now let's put the derivative on a number line to see when it's increasing and decreasing. So I'm going to, here's my number line, and I'm going to put the derivative on here, and the derivative had, I'm just going to write it down here again. There we go. And there's 3 parts to it. The -2, which is going to be negative all the way across, and then the cosine of x. And sometimes it's easier to look at the graphs of these things to figure out where it's positive and negative. So the cosine of x is positive in these areas here. So between, it's going to switch at pi over 2 and at 3 pi over 2. So I'm going to put 0 is where I start. I'm going to only worry about between 0 and 2 pi. And at pi over 2, it's positive in this area and negative between those, and then positive again. And then I'll do the next one, which is sine x, maybe change the color, sine x plus 1. So if I graph sine x plus 1, it's a sine wave that's been moved up 1. So it looks like this. And notice that it will always be positive all the way across. So there's really no big calculations you need to make. It's always going to be positive. So that tells me right here that in this area it's going to be a negative. The derivative is going to be positive here, and it's going to be negative here, which means the function is decreasing, increasing, and back to decreasing. So it's increasing between 0 and, sorry, that's not right. It's increasing in the middle piece there between, in here, between 3 pi, sorry, pi over 2 and 3 pi over 2. And it's decreasing between 0 and pi over 2 and 3 pi over 2 and 2 pi. So that tells you a little bit as well where the max and min are. And the min, there's going to be a min value here at x equals pi over 2, and a max value at x equals 3 pi over 2. So let's figure out how high and how low this graph goes when x is pi over 2 and 3 pi over 2. So for that, I'm going to go back to my original function, which is cosine squared x minus 2 sine x, and I'm going to figure out what happens at pi over 2. So cosine pi over 2 squared minus 2 sine pi over 2. Cosine of pi over 2 is 0. Sine of pi over 2 is 1. So it's -2. So the min value is at pi over 2, -2. This is the minimum. And the maximum, if you do the same thing, plug it back into the original function, This one again will be 0. This will be negative 1, so it's equal to 2. So the max is 3 pi over 2, 2. So I'm going to stop the video here and continue with concavity in the next video.